it, we're just gonna move on to chapter 1, and this is lesson 3, and we're converting rates. I already told you to take a picture of this chart. From now on, you can use this picture on tests or quizzes. I will tell you though, that is a chart that you need to have memorized, and you will need to use it and have it memorized. When you get into like NWEA questions or I-Learn questions, you will not have the chart as a reference, okay? So just because we're getting it here, you can use it. So we're gonna convert rates. And it just says the relationships among some commonly used customary metric units of measure are shown in the table below. So here they are, like 12 inches is a foot, okay? 16 ounces is a pound. And then you need to know some of those within that. It says each of the relationships in the tables can be written as a unit ratio, which is like a fraction. Like a unit rate, a unit ratio is one in which the denominator is 1. Below are 3 examples of unit ratios, like 12 inches is a foot, 16 ounces is 1 pound. We have the 1 on the bottom, which makes it that unit rate, because a unit is just 1. Then it says the numerator and denominator of each of the unit ratios are shown are equal. So the value of each ratio is 1. So because 12 inches equal a foot, that equals 1. Okay? Because it's just a different, one is in inches and one is in feet. You can convert one rate to an equivalent rate by multiplying by a unit ratio or its reciprocal. What is it when we do the reciprocal? Yeah, what do we do? I see this. Yeah, you're flipping that fraction. The denominator becomes the numerator becomes the denominator. You can convert when you convert rates, you include the units in your computation. So here's where it's important. We have to focus on the units. Yesterday when we went over the assignment, remember when I went over grading and you guys were changing like so many inches to feet or feet to inches? And remember I said I need everybody to set it up this way because it's going to come in handy later? Today is that later point. Okay, that's why we needed to do it. And then it says the process of including units of measure as factors when you compute is called dimensional analysis. That's a really big word. What I really need you to understand is when you do dimensional analysis is that you are trying to convert different units, like from inches to feet. And you have to learn to cancel out whatever you may need to cancel out. So let's look at our first example. It says, a remote control car travels at a rate of 10 feet per second. Now, I'm going to do some underlining and circling, and you need to do the same. This is what I started with, 10 feet per second. But then it asks how many inches per second is this? So then at the end, I want to end up with inches per second, and that one has a box around it. What I start with is underlined, what I end up with has a box around. Now, they give me an example here, but I'm going to show you step by step, and I want you to write it down. You always start with what you start with. So I'm going to write 10 feet per second. Then I don't know what it's going to end up being, but I do know my label at the end. What's my label at the end?
Feet per second.
No, feet per second.
Not feet, guys.
Inches per second.
Okay, so then I'm going to put inches per second. And order does matter. I can't do seconds per inch because I have to follow what it says. Then, okay, so that's what I have to end up being, my label. So then I come back and I look, feet. Do I have it ending up at feet at the end? Do I have my label as feet at the end?
No.
So that means I need to change my feet to
Inches.
Okay, so that's going to be my next thing. So now if I want to change my feet to inches, should feet be on top or the bottom? Bottom, because that's when I can cancel out those labels. That's how you know what goes on top and what goes on the bottom. Now I fill in my numbers. How many inches are in a foot?
12.
So 12 inches in 1 foot. Now my bottom is saying that it's feet per second. Do I want seconds at the end?
Yes.
So do I have to change anything with seconds?
No.
Nope, and then this is just a multiplication problem. 10 times 12 is 120, and then 1 times 1 is just 1. So it'd be 120 inches per second. Do you see how I do that? I'm gonna underline and box in my problem. Gonna show what I start with and show what my label is at the end. And then I'm gonna work with what I have to in between that. So let's go on to the second example. And I know they give you the answer, they give you step by step, but I want you to follow along with me doing it step by step. So swordfish can swim at a rate of 60 miles per hour. What do I need to put an underline around? 60 miles per hour. How many feet per hour is this? What do I put a box around? Feet per hour. So then I start with 60 miles per hour. So I put 60 miles per hour. What am I ending up with at the end? I just want my labels.
Feet per hour.
So it's feet per hour. And notice I give myself a lot of space here. So then, I'm looking at miles. Do I need to change from mile? Is it ending with miles? Nope, it's ending with feet. So I need to change my miles to
Feet.
Okay, so should miles be at the top or at the bottom?
Bottom.
Bottom, because then that can cancel each other out.